This is part two of building a Jewel Defender game for the Playdate. First session, we created this where you can press A, you move the tank around, but it doesn't actually rotate with the left and right button presses. The spinner does actually spin the tank. I'm thinking that the left and right should actually be rotating the tank, and forward and backward should make it go forward and backwards based upon which way the tank is pointed. Um, so some of the things that we're going to try and do is move the game source files to a source directory. I was finding that having various different informational files and development files in the same directory as the main.lua, when you build it, it tries to incorporate all those into the build file. We don't really need to have that. There's ASprite files and stuff like that that need to be in our project directory, but should not be compiled into the final product. So that's one thing. We need to create a build run bash script. So instead of typing out this command every single time, it would be something more like .start.sh, something like that. Make turning actually work correctly. Make it so you can shoot. Add some enemies. Make it so you can shoot and kill enemies. Add the jewels to the screen. Make it so enemies move to take jewels, and then, come up with more tasks probably for the next session. So first things first, let's make a directory called source, and let's move star into source. All right, so now we have this source directory, which has all of the images, main Lua, and the to-do items. Let's move those back up to the top level directory because we don't want to have the to-do in the actual build. So that gets rid of this. Next, we want to create a bash script. So touch start.sh, code start.sh, and it's going to be kind of like this. Now, if you remember, when PDC, which is compiles, took the current directory and put it into the parent to this project directory, instead we're going to have it actually output to the PDX into this directory. So let's first copy this. We're going to make it take the source directory, and it's going to output it towards the current directory, and then we're going to open the file that it creates. So, and change its permissions to be read and writable. All right. And it's working. All right. Make turning actually work correctly. All right. So let's get rid of some of these excess comments to shorten up this. of some things by making Playdate as a defined global. All right. Does that actually change in settings or something? It doesn't matter. Okay. All right, so that's pretty good. Just wanted to clean it up so it's a little smaller. So the first thing that we need to do is we need to go into the controls here, and we need to change it. I think we're going to, for now, we're going to remove the crank position as the adjuster. We might do some things where you have the option of using the crank to turn. We also might make it so that the crank can maybe turn a turret on top of the tank. Haven't quite figured out what I want to do with all that. But for now, let's just get rid of this. And we are going to make it so left and right set rotation of this. So first let's get the rotation of the object. So we want to first take the right and the left, and we want to make those become based on rotation. So let's group them together. So we got up and down here. We got left and right at the bottom. So for this, we're going to make it so instead of moving to the right, we're going to take the set rotation, and we're going to do get rotation and plus 1. Minus 1. So the rotation will be subtracted, and that's what will set the rotation. Looking at the guide, this may or may not cause performance issues. We're going to do this right now, and then maybe abstract away something that can be more performant later. So let's try starting it up. All right, so that's pretty slow. I see a little jump there for some reason. I'm not sure what that jump is for. Let's try maybe 3 at a time. Much smoother. Seems to have problems right around the 90-degree rotation mark. All right. So now forward and backwards needs to be sorted out. So looking at this, it seems that right at the 90-degree mark is where it's having an issue. let's do a print of exactly what is going on there. So 90, it's jumps down a little bit. 84, 90, 99. So I wonder if we do 3.1, so it never really precisely hits it. Will that resolve the problem? It does. Alright. Well, that's good for now. Now we need to adjust the position X and Y. So one thing we want to do is game screen update. Player sprite is this. I wonder if I can say player sprite velocity. Let's see how much I can start tacking onto this. So player sprite equals 0. So we're going to start out with that, and then we can say so first we'll include a little bit of physics slowdown. So we'll say player sprite velocity equals player sprite velocity times 0.9. So this will slowly decrease it. And when you press up, it will increase the speed. So player sprite velocity equals velocity plus 2. We'll do the same, -2. And we're going to do something where we actually do the movement based on velocity. So what we're going to first do, though, is see if velocity actually is preserved. So it's 0. You can see it changes dynamically right there. You can go faster and slower. Alright, that's pretty cool. Let's so this is how to get linear velocity from a rotation and a velocity. So let's give that a try. So All right. This is something we keep accessing, so let's change this to rotation. I'll change this to rotation. Local rotation equals that. We want rotation and player sprite dot velocity. And we can just make this x vx vy. I wonder local vx vy equals that. Can we do that? Nope, can't do that. Local v equals that. Wait, just x and y then. Vx. Let's see if alright, so that seems to be able to figure out Vx. So let's try v.x, v.y. So now we can move it along by an angle. Whoa. All right. So we should have a max x and max y, max velocity. We'll have it be 2 and if player sprite dot velocity is greater than max velocity, then it's equal to that. Alright, so now it's not going to go too fast. That's pretty nice. Oh. You make velocity negative for when you're going backwards. Velocity. Let's make the forward velocity be able to go a little bit faster than backwards. need to slow down the acceleration a bit. Let's make it go faster forward than backwards. Let's juice it up a little bit more. Now we can also make it so I can always make it so the crank position also comes into play for the rotation. So first, last crank position. Equals get crank position. So what we're going to do is we're going to make it so these two values can get added to the rotation. So and let's say instead of doing this, we could actually say rotation equals this. Equals this. And we could say rotation equals this. And we'll say local starting rotation equals rotation. Okay. And we could say so whenever, so if knit rotation not equal to rotation, changes, set the rotation. Alright, so that still works. And then last crank position. So if crank position, if it's not equal to last crank position, then what we do is we're going to change the rotation equals rotation plus this minus this. And I'm not sure if that direction's right, but we'll find out. Oh, nice. So you can quickly spin using the crank. And then you can also do both at the same time, really. Give you a couple more options for how to steer and shoot. All right. So now we've made it so turning actually works correctly. Next, we need to make it so you can shoot. If button is pressed, we'll make it the A button. And then print, bang. All right. So I notice that it is happening twice for each thing. So if I press it once, it happens twice. I think at this point we're going to end the video, and we'll continue on with continuing to make them shoot and then adding enemies in the next video.